Okay, so today we're going to talk about dilation. So all of you went to the presentation, missed this lesson. So dilations we did in with similar triangles. So dilation is when you essentially make a shape twice as big or half as small or some ratio of the image to the pre-image. Remember, the pre-image is the original and the image would be the new one. So the dilation factor or the scale factor is the new divided by the old, right? So it's either new divided by old, or you also might see that as image divided by pre-image. If the dilation factor is bigger than 1, that means it's going to be an enlargement. The new shape is going to be bigger than the old shape, and if it's less than 1, then it's going to be a reduction. If it's equal to 1, then the two shapes are going to be congruent. The other thing we're going to use today that we did before was the partitions of lines. So back when we had the yarn and we tied it into knots, and then we talked about how much it is to get from one knot to the next knot. And when we put that on a grid, we said we'd like go over 3 and up 2 to get to the first knot, and then over 3 again and up 2 to get to the second knot, and over 3 and up 2 again to get the third knot. That idea of doing the sections is going to come in handy for today too. So a dilation has to have two things, whether it's a dilation of a line or a polygon or a circle, a polygon being a triangle, square, something that has sides and is a closed shape. It has to have a center of dilation that tells you where you're dilating from, where are you stretching your shape from, and a dilation factor or scale factor, which is telling you how much bigger it's going to get or how much smaller it's going to be. That's called K. So if we first start with dilations of lines, so the first thing we want to do is plot the original line. So A is going to be -3, 2. So if we plot that point, and you have this paper, this is the notes paper with all these examples on it, and then you have the point 1, 3. So if I draw a line between those two points, this is line RS. So if I label that line, I'm going to get hopefully smaller. I'm sorry, not line RS, this is line A, and then on this side it's line B. So that's my original, my pre-image, my original shape. So we're going to dilate, it says, from the center being at 0, 0. So I'm going to draw a new axis, right? Kind of like our Back to the Future axis. It's going to be green. Actually, maybe I should make it yellow. It might be easier to see. This is my new axis. This is where I'm dilating from. In this case, it's the same as the origin, and my scale factor is a 3. So every point is going to move 3 times as far from the origin. So if we look at the first point on there, A, to get to A, we're going to go left 1, 2, 3, and up 2. Now we need to go 3 times as far. So you still start back at the origin, that little yellow cross, start back there. So we're going to go left 3, up 2, and we have to do that 3 times. So we do it again, left 3, up 2, and we do it again. We've now moved A 3 times as far. So the key is that to make sure that you use, when you go 3 times, you start from the new yellow origin. Don't do 3 times from A. So that's going to be our A prime. So if I label that A prime, okay, so that's A prime. So we're going to do the same thing with B. So if we look at B and we draw our point, so if I look at B, I'm not sure, not purple anymore, but okay. To get to B, it's going to be right 1, up 3. Right 1, up 3. And then I'm going to do it 3 times. So I need to do one more, right 1, up 3, and do it again. Right 1, up 3. And that is going to be our B prime. And I can label that B prime. Remember, the new shapes are always labeled with the primes. Okay, so if I draw a line between my A prime and my B prime, make it red to match the dots. So if I draw a line between there, if you look at AB, and you look at A prime, B prime, you'll see that they have the same slope. So those lines are parallel. That is always true. Every time you dilate a line, the dilation will always be parallel to the original. You also, if you remember when we did triangles, when we dilated it, each side on the new triangle was 3 times as big as the side on the original triangle. Same thing with these. A prime, B prime is 3 times as big as AB. Okay. So if we go to example number 2, we're going to do again, we're going to draw our 2 points, 3, negative 4. So that's R. And negative 2, negative 3, that's S. So that's S. And this is R. And so if I put a line between those, this is my original. This is my pre-image, which is my original one. Now here the dilation factor is 2 and the center is negative 1, 2. So when we draw our new axis line, it's going to be at negative 1, 2, which is up here. Negative 1, 2. So when we dilate, we're dilating from this point. So when I go to draw this and I say, okay, well, how far is S from the center? It is left 1 and then down 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So to go twice as far, I go left 1, down 5, and I go left 1, down 1, 2, 3, 4, 5. That's going to be my new S prime. Okay, we do the same thing with R. So starting from, again, the center of the green axis, we're going to go left 1, 2, 3, 4, and down 1, 2, 3, 4, 5, 6. So right 4, down 6. So I have to do that twice. So from the green axis, I go right 4, down 6. Sorry, right 1, 2, yeah, right 4, down 6, and I do it again. Right 1, 2, 3, 4, down 1, 2, 3, 4, 5, 6. And so that's my new point. So if I draw a line between those, somewhat close to the same color, maybe. Let's try that one. There's a line from S prime to R prime. Again, those lines are parallel. This is S prime, this is R prime. Those lines are parallel, and S prime R prime is twice as big as SR because the dilation factor is 2. If we do dilate a polygon, so such as triangle LMN, if we put our 3 points on there, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. So we put on L, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, and we put M, and we put N, 2, 3, 4, 5, 6. Okay, so my new shape is a triangle. You dilate this the same way you dilate a line. You just dilate all 3 points. And on this one, the center of dilation is negative 7, 8. So that means that all the way over here at negative 7, 1, 2, 3, 4, 5, 6, 7, and up 8, 1, 2, 3, 4, 5, 6, 7, 8. This is my center of dilation. So from that point, that's where I'm going to use my scale factor, which is 3. So I need to label my points. It's kind of a pain to go back and forth, but this is L, this one was M, this one was N. So now that I have my points labeled, so to get to L, I'm going to go right 1 and down 3. So I need to do that 3 times because my scale factor is 3. So I've already done it once. Right 1, down 3, right 1, down 3. This is my new L. Don't like that thick line as well. Okay, so if I do M, M is straight across 3 spots. So if I do that 3 times, I go across once, I go across twice, and I go across 3 times. So I should have a total of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's my new dot from M prime. And then if I go back to this, it's so much easier to see. n. So if I do n, it's going to be 1, 2, 3, 4, 5, down 2. And I need to do that 3 times total. So I've done it once. I need to do it 1, 2, 3, 4, 5, 1, 2, and 1, 2, 3, 4, 5. Lost track. 1, 2, 3, 4, 5, 1, 2. So this is my new spot for n. So if I draw lines between these, I have a point way down here, I have a point up here, and I have a point way over here. So if you look at this triangle, and if I label my points, this is L prime, this is M prime, and this is N prime. You'll see that the sides of each triangle are 3 times as big because the scale factor is 3. These triangles are similar because all of the sides have the same scale factor. So side, side, side similarity tells us that triangle LMN is similar to triangle L prime, M prime, N prime. If we think about the perimeter of each triangle, so the perimeter is adding the 3 sides together, so L plus M plus N. And in the new shape, the perimeter would be 3L plus 3M plus 3N. So the perimeter of the new shape, or the perimeter of the image is what I should call it, is 3 times as big as the pre-image. The area, because if you think about the formula for the area of a triangle is the base times the height. So the base is 3 times bigger, and the height is 3 times bigger. Sorry, over here, this base is 3 times bigger. This height is 3 times bigger. So therefore, when you multiply 3 times bigger and 3 times bigger, the area becomes, so the area of the image is 9 times bigger than the area of the pre-image, because you're multiplying the base times the height. This next one is very similar, except this one has a different dilation factor, so I want to make sure that we talk about that. So Q is at negative 2, 1. Negative 2, 1. Let me put that in the right spot. R is at negative 2, 7. 2, 3, 4, 5, 6, 7. S is at 4, 10. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way at the top. That's right. And T is at 4, 1. So if I label these points, because you should always label your points, you have Q, R, S, and T. Now if I draw the lines between them, black is the quickest. So I've got Q to T. So here's the shape that I have. So now I've got a 4-sided shape, a quadrilateral, and I want to dilate by a center of 1, negative 2. So that means that my center, 1, negative 2, is down here. And I have a scale factor of 1/3. So this is going to be a reduction because the scale factor is less than 1. So if I look at how far it is from the center to any one of these points, from the center to Q, it's 1, 2, 3, 1, 2, 3. So it's left 3 and up 3. So, oops, there we go. So for Q, it is left 3 and up 3. So if I go 1/3 as far, Q prime is going to be left 1 and up 1, because that's 1/3 of where we were before. So then my new point is going to be right here. Oops, left 1 and up 1. Everything's from that new red axis. So that's my first point. If I look at R, R is left 3 and up 9. R is left 3 and up 9. So that means that R prime is going to be 1/3 as far. So it's left 1 and up 3. So when I go to put my R prime in, it's going to be left 1 and up 1, 2, 3. So it's right here. Likewise, T is going to end up being right here, and S is going to end up being right here by the same process.